before we do any inflation, before we make a bubble, we want to get the glass evenly distributed on the end of the pipe. We want to get it on center. So she rolls smoothly in this wooden tool. It's been soaking in water. It just looks like a scoop or a ladle. But she gets a nice even shape. Also gets the temperature just right. That glass comes out of the oven, it's a lot like honey in consistency. So you won't want to inflate it when it's too hot because it would just be really too hard to control. So getting everything just right. Once she has that form, she'll probably pressurize the blowpipe. So we have the mouthpiece of the pipe, we blow into, cap a breath with our thumb, that creates the pressure needed to get the air in the pipe to push into the glass. If you watch closely, that was very subtle. Everybody catch that? Okay. Now that's the foundation that we're going to build on. If she wanted to make a really tiny base, she could do so with this amount of glass. But we want to make something larger scale, which requires a bit more. So look up at the screens here for a moment. This is a great visual of the inside of our melting furnace and how we gather glass from it. The white bowl that you see in the screens here, that's a ceramic crucible, pretty high-fired ceramic, so it's pretty strong. And at 2,100 degrees, we dip into the middle of that pot, submerge into that molten glass, and then turn very smoothly to wind that molten glass onto the end of the pipe. Literally, it's just like honey. So if you've ever got honey out of a honey jar with a dipping stick, it's the same way our glass would move. So what she's doing is now just allowing the bubble to drop in temperature. We need it to harden so we can gather more glass on it without that bubble kind of slumping offset or collapsing in on itself. So at times in the process, it looks like we're just doing nothing, but we're letting the temperatures get right. We say we're letting the glass cool. Cool is relative. 1,000 degrees is cold for our glass. That's where it's rock solid. But she's got a larger surface area established after making that bubble, so this time she can come out with about 3 times the quantity of glass. And if you want to make something really large, you continue to do that process over and over and over again. These tools are called blocks, and they come in a bunch of different sizes, small all the way up to pretty large ones, and they are made from fruit woods. These are mostly cherry or apple, I think. Fruit woods burn away very evenly from the grain structure. They're also pretty clean when they burn. That's important, but they do have to be soaked in water to shape molten glass, otherwise it sticks right away. So just a nice even distribution. There's a lot of similarities between what we do with pottery. Potters get clay on the wheel and they center it on the wheel best they can, otherwise the clay kind of wobbles out of control. Potters use their hands a lot. We can't obviously use our bare hands, but there's another tool that you'll probably use that gets our hands pretty close to it. Now, adding water to clay to keep it soft is basically the same for heat to glass. So we have a secondary reheating oven for that purpose. And you get this really neat view in the backside of our oven every time we use this. I'll talk a little bit more about that in a moment. But Katie has now attached a blowing tube to the mouthpiece of the pipe. So during the pandemic, when our staff were here working with a mask wearing requirement, we couldn't put our mouth in the pipe and blow through. This is the system that we used. Now, a couple of you over here might be able to see it. There's a foot pedal that's right in front of her. She'll tap that pedal, that lets air pressure through the system. So if you see the bubble getting bigger, it's getting slightly bigger right now, she's pressing on that foot pedal.
Is that a cuff of the glove?
What's that?
Is that a cuff of the glove?
No, so that is actually the tool that I was mentioning that gets our hands pretty close to it. We have another one over here. This one's a little bit beat up. Can anybody tell me what this tool is? Newspaper. Yeah, it's folded up layers of newspaper, and it works really, really well. Somebody asked us a week ago, why don't you use a kitchen towel? And I don't know if you've ever grabbed a hot skillet with a wet kitchen towel. Bad idea. Probably the last time you do it. The heat goes right through and burns your hand. Paper is so dense, the fibers are so dense, that you can shape with it molten glass and the heat doesn't go all the way through the bottom. Now it looks thinner than it actually is because it's been soaked in water and compressed so much. This one's totally dry, so you have to wet it first. But it's about as close as we can get our hands to shaping the material. But you're gonna see Katie make a lot of trips back and forth from the oven to the bench. Bench is where most of the shaping happens. The oven is where all the resoftening happens. So keep the glass at a higher temperature in a soft state. The camera providing this view is safely mounted behind this oven. It looks through a small window of a very special high temperature resistant glass called fused silica. and you'd have to get that oven well above 3,000 degrees to do anything to that window. That oven is set right now at 2,000. But keep in mind as you watch this process, Michael and Katie both have lots of experience. Katie's been blowing glass for 10 years full time. She's got a lot of skill, muscle memory to be able to turn the pipe so smoothly. It looks pretty effortless when you have skilled glass blowers, but that's deceiving. It takes most people a few solid years just to get the basics, the fundamentals down. She's putting beeswax on that tool. It's a metal bladed tool. They're not very sharp blades. They're like a butter knife on the edge. They're called jacks, and they are one of the most versatile tools that we have. They're a spring steel grip. Their primary function is to squeeze the jack blades over the bubble and form a constriction for a break-off line. But she's doing some contouring right now to begin making the middle of the body of the vase, the waist as we call it. We tend to use a lot of anatomy terminology, the foot, the waist, the neck, the lip of the form. But she's created this division between the bubble, kind of like a gourd shape going on. Using gravity as well. Gravity is a really good resource for glass blowing, letting the bubble stretch, elongate. So we can use the paper to shape a little bit. We can use it to cool the glass at times. Every material, when you touch the glass, inevitably pulls heat from it. So if we're inflating, we might want to stop the bubble from blowing too thin in certain areas, and we can hold the paper or some other tool there while we're inflating. But she's got the basic profile of the body of the vessel. The next step here is to create the bottom. So we're going to add some glass for a stem, some glass for a foot, and then we'll flip the piece around and work on the top. You can see her squirting a little bit of water on the paper. That is important. So lots of teamwork goes into this. Usually you see us working in teams of two. Katie's got the bubble set up nicely. She's let this go rigid. She's kind of hung away from the heat long enough so the bubble isn't moving anymore. It allows her to add this gather glass comfortably and shape it into the stem. But this is where you're going to really see the jacks in their full glory here. So many ways to use that. She centers the glass on the tip of the bubble with the head of the tool, and then she'll flip it around and start to shape the profile of the stem using the blades. That wax is important. That wax just stops the metal from sticking to the glass, just to lubricate. So Michael stands by to start pressing on the very tip of that gather with a paddle. As Katie pulls the jacks towards that paddle, what they're doing is flattening a little section on the tip of the stem. We call that a button, and that's just an area that we can add more glass for the foot. So we're going to do this in two parts. Now, once she takes a reheat, I'm going to show you the tool that she'll use next. We have a couple of these out here. These footing tools are pretty simple in design. They're really tricky to work with though. Two pieces of wood hinged together. When we get these tools, they're just straight plain wood. We have to burn the notch out ourselves. But the notch grips the stem of the form once we get a gather on there. Squeeze the tool over as you turn into it, and it takes it and creates that nice foot shape. Which one do you want, the big one or the small one? This one? You got it. All right, no problem. Now Katie will make this look pretty easy, but this is a very challenging step. She's maintaining temperature at all times as well. You might notice you're using a torch, you're taking quick reheats. We can't let anything cool too much as we work it, otherwise the glass wants to crack from thermal shock. So the same application, spooling a gather on. Now to make this tool work properly, you do have to squeeze pretty hard, but this is where that left hand has to turn the pipe so smoothly, otherwise it just binds right up in the tool. She makes that look pretty effortless. I'd say we give her a big round of applause for that. Remember, 10 years of experience. Okay, so we're pretty much done with the bottom. Now fine-tune the shape of that a little bit. But if you look at any of these pieces, this has the stem and a foot on there. The tops of anything at one point was attached to the blowpipe. So we typically finish the bottom, then we'll attach a handle to the foot and call it a punty. We'll see Michael make one of those in a moment. Once we have a handle there, then we break the form free from the pipe, and that flips it around, essentially. And it's very traditional glass blowing. It's how most forms are made by hand. We'll make sure the foot is level, straight. Michael's using a dry wooden paddle at this point. In fact, you wouldn't want to put water on that tool now because that foot has lost so much heat that water can actually crack it. So there's times you need water, there's times you don't want to use water. All right. Our punty, just a little bit of glass gathered and shaped on a solid rod. Michael will bring it over to Katie and they'll attach it to the foot. Now, a pretty common question that we get a lot is how come you guys aren't wearing any gloves on your hands? How are you holding onto these metal pipes, not burning your hands? These are stainless steel, which is not a good conductor of heat. So you can see that this end actually is preheated right now to about 1,000 degrees, but the heat kind of works its way up and tapers off, and we can usually hold about 2/3 of the pipe okay. So if we don't need a glove, we don't want one on because we want full use of our hands and fingers for dexterity, able to use the tools and turn the pipes as smoothly as we can. But again, Katie maintains temperature throughout these quick reheats or maybe using that torch a little bit. You get a sense for how hot the glass is or how you need to keep it warm and the timing in doing that with years of doing it. Beginners don't have that internal timer. They let the glass cool just a little too much. It breaks, it cracks. The next piece you make, you try to keep it warm. You learn. All right, so they attach the punty. They roll back and forth a couple times just to make sure that everything is in line, keeping our center point. Katie adjusts the foot if she needs to. Now we can use a little thermal shock under control. Just going to do that with either cold steel or maybe a little water dropped on the glass. Water it is. So tiny cracks form in that one spot, and then a swift tap on the pipe should be enough to do the rest. Let's give her another round of applause. That was pretty well done. Got it. All right. Any questions? Okay. Yes. What fuel? Raw materials. What's glass made of? Anybody know the main ingredient?
Silica.
Silica, yep. Silica sand, soda ash, and limestone. Those three materials mixed together, you melt it down and it forms clear. A sample of it? Well, it's kind of hard to tell that it's silica sand. I mean, it basically just looks like, these almost all look like the same thing. That's a thing of silica sand right there. So it's a pretty fine particulate. It's basically the same consistency as like all-purpose flour, like kitchen flour. So you can melt regular sand, like beach sand down or desert sand, but it's pretty coarse and there's other things in there like rock and shell and debris and stuff that don't melt so clean. So silica sand or silicon dioxide, if you want the chemical name. This is mined out of the Earth's crust, so there are silica mines that are in the world. We don't mine the materials ourselves. You could mix the raw materials and create batch. What we melt has already gone through that mixing and melting, and it's called cullet. So there's a company that we buy bags of this from. It looks like an ice cube, but it's actually glass. So it's already gone through the mixing, the melting, and then this melts a lot faster with less heat than that. Because to melt the silica sand, you need a good amount of energy and a lot hotter furnace than this. But once it goes through that chemical change, this is a lot faster to melt down. So we really like this. Now this is all clear glass that Katie's working with. It's too late to add color to the body of the piece because it's already been blown up. But in the beginning, we can take a fresh gather of clear glass and roll through something called frit. It's just one method. These are little chips of crushed up colored glass. To make the color, companies mix in different metal oxides or metal chlorides, and they melt those ingredients down, metals change to color of glass. But back to what Katie's done. She's got some good heat worked into the top. She's opening a little bit further. Now, if you look at the drawing, this sort of wavy top that she has, that fluted edge, we're going to use a lot of heat, rotation, and gravity to finish this piece off. So she's just kind of building the heat into the areas that she wants to get the glass moving. And once this starts to go, it's going to happen pretty fast. She'll probably do this one more time, so the bench one more time, I'm guessing. But yeah, you see how it's ruffling right now already? That's one thing we're looking for. As we're heating, we're watching the way the glass is moving, and a good indicator of when we need to come out of that oven.
Is Kubler the same as Frit?
Kubler? Kubler's a company that makes glass color. Yep.
Okay.
Yep. All right, so watch this. I think Michael's going to give her a little bit more room in the oven. That's a good indicator of what's about to happen. So getting it nice and hot. She goes in for those deep reheats to make sure the foot and the bottom don't cool too much. Again, that flashy, but here we go. We're gonna see this open up quite a bit. In fact, she's picked up the speed a little bit of the turn. Yeah, check this out. Opens the top up pretty much totally flat. At the right moment, she hangs it to the ground and slows the turn, and that's how we get that beautiful ruffled edge. What do you guys think? Nice job. All right, so again, using a torch right now, she's letting the top of the piece cool a little bit so it turns rigid, but she's keeping the bottom, which is pretty thin, warm enough before breaking it free. But the final step for anything we make is a slow cooling process. The oven that I'm standing next to is called an annealer, and it's holding right now at about 960 degrees. We put all the work we make today into this oven, and it slowly drops to room temperature overnight. It takes about 8 hours. So a little water on the putty to weaken it, quick tap, that's all it takes to do it. Nicely done. A beautiful piece. Away it goes. Now this oven is programmed to slowly reduce room temperature, and when we run the program on the computer controller, that's what it's going to do. Well, let's give the team another big round of applause. Excellent job. All right, are there any other questions? Yes, ma'am. Can you speak up just a bit?
Unboxed by me.
It is reusable, yeah. So if we make a piece and it breaks and it's clear glass, we will remelt it. Yep. But if you mix color in there, you wouldn't want to remelt it in that furnace because that's all good clear glass, and the color would just kind of contaminate it. Yeah, but you can. And it's a good idea too when you have beginners to have them work with clear, not just because you can remelt it. Color's pretty expensive. So if you start working with some expensive color and you're going to fail a lot, you're going to be wasting money. Yeah. Yep. All right, folks, that's going to wrap it up for this show. Thanks so much for coming to see us today. We're open till 5. Enjoy it. Bye-bye.
Thank you.